All right, let's dive right in. We're about to explore some of the weirdest, most unbelievable facts about our universe. I'm talking about things that sound completely made up, but are absolutely 100% true. Let's get to it.
So I want to kick things off with a question for you, and it seems like it should have a really simple answer. Which are there more of? Trees on our planet Earth, or stars in our galaxy, the Milky Way? Just take a second and really think about it.
So on one side, you've got our planet, right? You can picture it, just covered in forests. And on the other, you have the Milky Way, this huge, endless sea of stars. One feels real, tangible, and the other just feels, well, astronomical. So what's it going to be? Got your answer?
Believe it or not, the answer is trees. Yeah, and honestly, it is not even a close call. One major study estimated that there are about 3 trillion trees on Earth. Just try to wrap your head around that number for a second. It's so big, our brains aren't really even built to process it.
Okay, so let's put that 3 trillion number into perspective. NASA thinks there are somewhere between, say, 100 and 400 billion stars in the Milky Way. So even if we take that highest possible number, 400 billion, that means we have more than 7 times as many trees right here on Earth as there are stars in our entire galaxy. It just goes to show you, when you're talking about the scale of the cosmos versus our own world, your gut feeling can be way, way off.
And you know what? That kind of weirdness, it starts right here in our own cosmic backyard. You don't have to go looking out into deep space to find stuff that sounds like it's straight out of a sci-fi movie. Our solar system is just full of strange little quirks.
Let's just rattle off a few, okay? First up, our moon, not a perfect sphere. It's actually kind of lemon-shaped, thanks to the way Earth's gravity pulled on it a long, long time ago. And get this, you could take every single other planet in our solar system and fit them all in the gap between the Earth and the moon. Wild, right? Oh, and over on Venus, a single day lasts longer than its whole year.
And then we've got Saturn. Saturn is so not dense, its average density is actually less than water. I mean, it's a gas giant, mostly hydrogen and helium, so it's huge, but also super fluffy. This quote just nails it, right? If you had a bathtub big enough, the whole planet would just float. Picture that for a second.
And it's not just planets and moons that are weird either. Astronomers have found this giant cloud of dust right at the center of our galaxy, and it's full of this chemical called ethyl formate. Now, why does that matter? Because that is the exact same chemical that makes raspberries taste like raspberries and makes rum smell like rum. So yeah, the heart of the Milky Way basically smells like a raspberry rum cocktail. Okay, so let's pull things back from these crazy cosmic facts to something super practical. Because all those strange, mind-bending rules that run the universe, turns out you use them every single day, and they're right there in the palm of your hand.
Just think about the last time you pulled out your phone to get directions. That little map app tells you exactly where you are, right down to a few feet. It totally feels like magic. But what's really happening is, well, it's a masterclass in applied physics. So how on earth does it work? I mean, how does this little thing in your pocket know its exact spot on a planet that's spinning and flying through space, all by listening to signals from satellites thousands of miles away?
Well, it's a process called trilateration. Basically, your phone is always listening for signals from a whole network of GPS satellites up in orbit. Each one of those signals is like a little timestamp. Your phone takes that timestamp, compares it to its own clock, and figures out exactly how far away it is from that satellite. Once it gets a lock on at least 4 of them, boom, it can pinpoint your location. And all that constant math, by the way, is the reason your phone tends to get a little warm when you're using your maps.
But there's a huge catch. For any of that to work, the timing has to be incredibly, ridiculously precise. The atomic clocks on those satellites and the clocks here on Earth need to be perfectly in sync. And here's the problem. Thanks to some guy named Albert Einstein, we know that's just not possible.
Okay, so first you've got special relativity. The simple version is, the faster you go, the slower time ticks for you. And those GPS satellites, they are absolutely flying, zipping around the Earth at almost 4,000 meters a second. That speed makes their clocks run just a tiny bit slower than ours down here.
But wait, there's more. You also have to deal with general relativity. This one says that gravity actually bends time itself. The weaker the gravity, the faster time moves. Since the satellites are way up high, where Earth's gravity is weaker, their clocks actually speed up and run faster than ours. So you've got one effect slowing time down and another speeding it up. Which one wins?
Well, if we didn't constantly correct for both of those effects, the slowing down from speed and the speeding up from less gravity, our GPS would be off by almost 12 kilometers. Every single day, your phone would tell you that you're in the next city over. So yeah,
Every time you fire up your maps, you are literally using Einstein's theories of relativity to find your way.
All right, so we've seen how these cosmic rules have a real impact on our everyday lives. Now let's head back out into the deep end, because if you thought floating planets and time-warping satellites were weird, oh boy, we're just getting started. Okay, think about this. Here on Earth, if you touch two pieces of metal together, nothing really happens. That's because there's always this super thin, invisible layer of rust, or oxidation, that keeps the atoms from actually meeting. But in the vacuum of space, that layer doesn't form. So if you take two clean pieces of the same metal and just touch them, their atoms just start bonding. They fuse together, permanently. It's called cold welding, and it's a massive headache for anyone trying to build things in space.
The sheer density of things out in space can just break your brain. Take a neutron star. This is what's left over when a giant star dies and collapses in on itself. It's so dense, this quote is really the only way to even start to understand it. A single teaspoon of a neutron star would weigh more than the entire human population. Like, take all of us, every single person, and squish us down into something smaller than a sugar cube. That's the density we're dealing with.
And the power out there? It's just as insane. The most powerful explosions in the universe are called gamma-ray bursts. They're these incredibly intense but very short flashes of energy that probably happen when a huge star collapses or two neutron stars smash into each other. The amount of energy one of these things unleashes in just 10 seconds is more than our sun will produce in its entire 10 billion-year lifespan. It's just staggering.
Okay, for this last part, we're going to shift gears a little bit. We're going from talking about crazy facts about the universe to asking a crazy question about the nature of the universe itself. The big question is the reality we see around us even real?
Now, this sounds like something out of a movie, but it's a serious idea in physics. It comes from something called quantum entanglement, where you can link two particles together, and whatever you do to one instantly affects the other, no matter how far apart they are, even if they're on opposite sides of the universe. Some physicists think this means that distance and space as we know them might just be an illusion, that space isn't a real thing, but something that just sort of emerges from these deeper quantum connections.
So where do we fit into all this? Let's imagine a scale of size. On one end, you have the smallest possible thing that can exist, and on the other, you have the entire known universe. Where would a person be on that line? You'd probably think we'd be way, way down at the small end, right? But it turns out we're actually just past the halfway point. We are, bizarrely, a little bit closer in scale to the entire universe than we are to the tiniest thing.
And that's really the thought I want to leave you with. We've just talked about how there are more trees than stars in our galaxy, how our own solar system is a funhouse of weirdness, and how space itself might not even be fundamental. So if the universe operates on rules that are this strange, this counterintuitive, it really makes you wonder, doesn't it? What other basic, fundamental truths that we take for granted are actually completely wrong? Thanks for joining me on this one.